Welcome to this demonstration of Treeminer's auto-clustering solution. In this video, we will demonstrate the automatic clustering of text documents in a Hadoop environment, inspection of the clusters found, generation of a classification model from the clustering results, and finally, the application of that classification model to a large collection of documents to identify other matches in both Hadoop and Storm environments. For this demonstration, we'll use a publicly available collection of emails from the top leadership at Enron Corporation. To demonstrate auto-clustering, we will divide the emails of one senior leader, Kim Watson, into clusters of related emails. Our demonstration environment consists of a client node where the Hadoop job is submitted from, a name node and job tracker for the Hadoop cluster, the Hadoop cluster where the jobs will be run, and finally, an accumulo database where we will store the results. The first step is to load the email collection into the Hadoop file system. This process takes the emails and stores them in an efficient sequence file format on the Hadoop cluster. Next, we run a Hadoop job that will parse the emails. The emails are assigned a globally unique UUID for tracking as they are parsed. Finally, we run a job to auto-cluster the documents. Our auto-clustering algorithm allows a user to specify how fine-grained the clusters should be. We evaluate the structure of the cluster to determine whether it is a real cluster or not. Here we see a dense, uniform cluster. This indicates a set of documents closely related. Next, we see a cluster that is dense, but not uniform. This indicates a set of documents that are related, with a few documents related but may be slightly off topic. Finally, we see a cluster that is not dense. This cluster will be further inspected to find subclusters within it. We launch the job. As clusters are found, information about the cluster is stored in the accumulo database. Using our cluster browser, we can inspect the clusters found by the algorithm. We see the documents found, as well as a score indicating how close the document is to the core theme of the cluster. We can also preview the document itself. Here we see a cluster containing multiple emails related to expenses for Trans-Western Pipeline. Let's investigate one cluster, Cluster 140. We automatically display a set of keywords as a hint to the concepts in the cluster. In this case, the cluster contains tariff and rate agreements with Trans-Western Pipeline. Imagine that this subject interests us, and we want to look for similar documents in the larger document set. To do this, we can directly build a classification model and run that model on a set of 500,000 emails from many other Enron executives. To show the flexibility of our approach, we will see the application of that classification model in both a Hadoop environment, where a vast store of data might exist, and a streaming environment, where we evaluate emails as they are arriving real-time. First, we'll show using the classification model for cluster 140 in Hadoop against this large email store. We were able to classify this entire dataset on one Hadoop node in under 7 minutes due to our vertical data organization and attribute selection. The addition of Hadoop nodes shortens that time by executing against the attributes in parallel. If we look at the results of the classification job, we found other documents which are near perfect matches for the documents in cluster 140. Here is one example where we compare a document found in the larger document set with a sample document from cluster 140. They are clearly related. Next, we will show the use of that exact same model in a streaming environment. Our 7-node Storm cluster can directly read the classification model from the Hadoop file system and apply it to an arriving stream of document. First, we start streaming documents into the Storm cluster. Here, we see the statistics of our Storm topology, showing the data being processed. Finally, we see that results are displayed real-time as the documents are processed. Results are displayed as soon as they are obtained. We set some thresholds to our capture. Here we only look at documents with a match score of 60% or higher. The red bar indicates a match. We can click on the link to find the global UUID for the document. And use our REST API to get details on that document. Here we see the file name, as well as a preview of the text inside that file. You can see that the text contains a tariff and rate legal filing for Transwestern Pipeline. Again, a document conceptually related to the documents in cluster 140. This overall flow of documents into the Storm cluster and the classification of them runs at over 10 megabytes per second. This performance graph shows that the classification speed scales as we add more nodes to help do some of the work. In conclusion, we showed the automatic clustering of text documents in Hadoop, building a classification model directly from the clustering results, and the classification of a large document set in both Hadoop and streaming environments. For more information, visit us on the web at www.TreeminerAutoClustering.com.